Assalamu alaikum. Our project is Rice Inspection System. Group members are Hamza Durez and Zafar Iqbal, which is supervised by Dr. Jamal Hussain Shah. Purpose of our project is to detect rice grains from an image. For this purpose, we are using some modern techniques of machine learning and computer vision to detect objects from an image, which are basically rice grains, and by detecting these objects we are predicting the types of rice grains. Before this inspection was done manually, which was very ineffective and not accurate, and it was very time consuming. This manual process is very less effective and not reliable for any consumer. So we are developing an automatic system for inspecting the type of rice, which is very reliable and accurate, and its efficiency is increased according to these algorithms of artificial neural network and VGG16, and these model will predict the type very effectively. So the objective of this product is to ensure the type and quality of the rice, and consumer can analyze the type rice with very effective, reliable and in a cost effective way. This project can be adopted by the industry for import checkup. Uh, Consumer can add analyze data as well. We are using Windows operating system, and for environments we are using Google Colab, which provides us a GPU for that to train our deep learning and convolutional neural network. And Django is used as a web framework to provide a very user friendly interactive interface for a consumer. So this product is to ensure the trustworthy of a consumer by not scamming in any case. This product can also boost the export of the rice and ensure the best quality by detecting the type of the rice. So we are using hardware for that. We are using a smartphone cameras to take an image of rice samples. Smartphone is easily available, and today it is used by everyone, which is not very expensive product. So we have implemented VGG16, which contains the 16 layers for convolutional neural network. Here is a summary of our deep learning convolutional neural network. Let's move towards the user-friendly interface, which is implemented in Jago. It Here is our dashboard, which we have created in Python Django's framework, in which we have used HTML, CSS and Bootstrap for that. It is very easy to use and user friendly. This dashboards contain a sample weight for a user and total weight of a rice grain, and which it will also predict the price for rice samples. So there are two graphs will be shown when we will import an image and upload it to our framework. The first one is will show about the rice grain type samples which are detected in an image, and then pie chart which will show the ratio for every chart. And if we scroll a little bit down, a table will also be displayed here, which will show the average size of a rice sample and its category. Let's import an image in our framework. This is an image we are going to import. Let's upload it. So if we look toward our chart, it shows what type of rice in an images are and how many rice it contains. There is also a pie chart for that, which shows the ratio for every single rice grain. If we scroll a little bit down, it shows that it has detected 10 samples from an image, which shows every average size for a single grain and its category. whether it is medium or bold.
Let's move towards the Python code which we have implemented in Google Colabs. Google Colabs provide us a GPU which is very beneficial for us to train our BGG models or convolutional models which contains deep learning layers. So here we have imported some useful and necessary libraries for our mod project. The very useful first one library is CV2, which allow us to import images and rewrite them, and we have performed some image processing, segmentation, and image localization techniques on that by using some morphological techniques and also some contouring techniques to detect an each grain form rise of an image from an image. So we are using TensorFlow, which contains the pre-trained models or predefined models of convolutional or deep learning networks, which is very useful and provided by Python to us. We are importing these models from TensorFlow, which is open source deep learning library. And we are also using Matplotlib to plot our graphs and showing the accuracy and converting them into binary scale images. And on binary scale images, we are reducing noise and applying some canny edge detection techniques, and then we are using CV2 contours, which are very helpful for detecting an object. We have multiple objects and rise samples in our image. So by using some contours, we are detecting each single grain, and also we are getting the size and dimension of each grain. Firstly, we have import our datasets which contain into training dataset and some validation or testing dataset. We are using VGG16 as I have described earlier. We are importing it, and we have defined some weight for that, and there are a total 16 layers for that. We are also using artificial neural network, and now we are flattened our image. Basically, in image segmentation, we are flattening our image, which provide an image into a vector, and that vector is contains the features of an image. We have total number of folders 5, and we are using that for our model training and testing purpose. Here is a summary of our model. First one layer is usually an input layer, the layer which we are giving to an input to our model. We are using convolutional 2D, which provides a kernel to an image and which is helpful to extracting the useful feature. And we are using max pooling 2D, which extracts some features from an image by a point of interest or region of interest. Here is a complete summary for our model. Then we are compiling our model. We have defined its loss parameter. Optimizer we have set it to Adam, and matrices we have used an accuracy matrix for that. Then we are reshaping our images by using the TensorFlow image data generator and resizing the image and completely defining its shape. We have our training data set, we have set its pass, and we have batch size for each data set is 250. We are using 80 epochs. Epochs are basically number of iterations which we are performing on our data set, which iterate on our data set and selects the random images from that. We have some validation data set, and we have total number of classes are 5, and these are the classes which we are using by a local data set from our image. Thank you.